Bueno, muchísimas gracias a todos los que están aquí presentes. Para los que no me conocen, soy el doctor Axel Barceló, investigador de este Instituto de Investigaciones Filosóficas y hasta hace poco coordinador del posgrado en Filosofía de la Ciencia. Y dado que el director de nuestro instituto, el doctor Pedro Stepanenko, tuvo que ausentarse, igual que nuestro secretario académico Edgar González Varela, me pidieron que yo inaugurara este taller Pluralismo Matemático, que tendrá lugar el día de hoy a partir de estos minutos y el día de mañana aquí en la aula José Gauss. Y esto, por supuesto, para mí es un gran honor. La gente que me conoce sabe que he estado apoyando la filosofía de las matemáticas en este instituto desde hace varios años, y entonces para mí me da mucho gusto. Le hacía un chiste a Luis hace unos días que me da mucho gusto, que era el primer coloquio o conferencia de filosofía de las matemáticas en el instituto que no organizo yo en los últimos 15 años, lo cual es muy bueno. I'm sorry for the people who don't speak Spanish. I'm very happy that, or very little Spanish. Luis Estrada is the organizer, and he's done a great job. He's very young, one of our youngest professors at the Institute, and I'm very glad that he's now part of our research team, because among other things, he's been doing this great work organizing a lot of seminars, and now this couple of workshops. We just finished a workshop on the nature of logic, and now this workshop on mathematical pluralism. And I was just joking that this is the first colloquium in the philosophy of mathematics. We commonly have colloquiums, at least one or two, on the philosophy of mathematics here at the Institute, but this is the first time in like 15 years that I'm not the organizer, and it makes me very happy. And also because it's a great deal. We have great guests, probably, yeah, really great. And also, since I didn't have a lot to do, lo único que me queda es pues pasar la palabra a Luis Estrada, agradecer a todos ustedes que estén participando, pues celebrar que estamos haciendo filosofía de las matemáticas juntos y recordarles que las conferencias se dan en inglés, pero eso no significa, y bueno, no va a haber traducción simultánea, no tenemos muchos recursos, pero si ustedes tienen algún problema para entender cualquier cosa, por favor, no les dé pena pedirle a los que están presentando que clarifiquen las cosas o que hablen más lento o cosas por el estilo. También si tienen alguna pregunta, están bienvenidos a la sección de preguntas y respuestas en hacerla en español, y nosotros trataremos de comunicarles su pregunta y luego traducir del español al inglés. And I also would like to remind our native English speakers that we are not. And so would you be able so kind to please speak slower than usual and try to be even more clear for us, please. Okay, so this is now Luis Estrada.
Gracias, Axel. Gracias por cumplir este rol de inaugurar el evento. La tragedia me persigue y ya hubiera sido el segundo taller que
no tenía inauguración.
Ya no tenía inauguración oficial. Entonces, muchas gracias por eso. Y gracias a ustedes por venir. Veo algunos sobrevivientes del taller pasado, eso me da mucho gusto. Y bueno, no estoy particularmente feliz de ahora organizar estas cosas que organiza mejor Axel. Entonces, ya veremos qué pasa el año próximo. Pero estoy muy contento de que hayan venido, de la recepción que han tenido los eventos, y las pláticas han sido muy buenas. Yo me he divertido mucho, así que estoy contento por eso. Dado que me están grabando, agradeceré a las autoridades que no están presentes, a Edgar, porque aunque no vino a inaugurar, me ha ayudado mucho. El director también, dentro de sus múltiples ocupaciones, me ha ayudado mucho. Mis colegas, Axel, otros que no están aquí ahora, Raimundo, Atocha, Alessandro. No voy a nombrarlos a todos porque me tomaría mucho tiempo, pero les agradezco a ellos. Y ya saben también que a los estudiantes asociados, también son mis colegas, también me han ayudado mucho y se los agradezco. Espero que disfruten esto tanto como yo. Es lo único que quería decirles. Y por último, ya para entrar en la acción, I want to thank the speakers for joining the workshop. I'm glad you accepted the invitation and that you are now here. I'm pretty sure the talks and the discussion will be great. So it's now your time. Welcome.
There's not very many slides. Who's looking for it?
You were.
Oh, yeah. Okay, sorry. I thought I was usurping someone's position. Okay, sorry. That's me. You're the chair. Okay. I'm sorry.
Buenas tardes, good afternoon. I'll be the chair for this session, and before beginning, I'd like to introduce you to Michèle friend. I'll be making a little academic biography of this before beginning. So,
paradoxes.
Ms. Friend obtained her PhD in philosophy from the University of St. Andrews in 1997. She has taught in the philosophy at the University of Reading, at the London School of Economics, and at the University of Manchester. She's currently an associate professor at George Washington University. His Friend's areas of expertise include the philosophy of mathematics, philosophy of logic, the philosophy of science, metaphysics, epistemology, the philosophy of language, philosophy of ecological economics, and the philosophy of computation. She's the author of 2 books in the philosophy of mathematics, Introducing Philosophy of Mathematics, published in 2007, and Pluralism in Mathematics, published in 2014, as well as of several papers published in specialized journals such as Synthèse and Studia Logica, and in the periodic compilations such as the Logica Yearbook. Some of the philosophical topics she has delved into are logical and mathematical pluralism, structuralism, the foundations of mathematics, and the philosophical aspects of mathematical proofs. Ms. Friend has been invited to deliver keynote speeches in several universities, such as the University of St. Andrews, the University of Montreal, the University of Amsterdam, and the University of Rio Grande do Norte, among others. Without further ado, I now hand over to Ms. Friend. Thank you very much.
Okay, thank you. So I'm very pleased to be here. I'm very excited to be in Mexico. It's I was here once, but I was 4 years old, so I didn't form a very strong impression of the place, although I'm sure I enjoyed it. So it's very exciting for me to be here, and thank you for inviting me. And I think that because it's organized in such a way that there's a lot of time for discussion, I think this will be very good. All right, so I'm very sorry that I have to read out my paper. This is partly so that I get the words in the right order and I don't run over time. But I will try to speak slowly and in a way that everyone can understand. Because we have a lot of time, if you have any questions, do ask. And don't hesitate. All right, so I'm starting out with a sort of pre-introduction. Before setting out any particular arguments, let me remind you or tell of the levels of theories, mathematical and philosophical. This will be important for what I say in this presentation. So there's a lot of information on the slides, but I won't go through very many of them. So they'll be up for quite a long time, each of them. And I hope you can all see the bottom of them. Right, so there are statements in mathematics and philosophy at least 3 levels. At level 1 in mathematics, we have theorems, proofs, calculations, transformations, and so on. At level 1 in philosophy, we have we propound the content of a theory. So if you're a realist, you say something like the number 4 is real. At level 2 in mathematics, we talk of theories. We might compare theories or individual results, keeping in mind the context or the theory in which the result is couched. At level 2 in philosophy, we make statements about traditional philosophies, or we compare traditional philosophies to each other. So we might say fictionalism is an anti-realist position with respect to the ontology, which is different from realism in ontology and in realist philosophy and mathematics. We can mix mathematics and philosophy at different levels. If we're worried about contradictions, then we are careful and we tend to refer only downwards, following Tarski. But I understand that in this room, we're not so worried about contradictions, so it's delightful to be in such an audience. At level 3 in mathematics, we might note the theory in which we are making the comparison, or make very general statements about all of mathematics. At level 3 in philosophy, we would make statements about philosophy of mathematics as it is traditionally developed. The levels are cumulative, so reference can be at least to anything below the level where we're situated. So this is just to give you a basic schema, and it's not, it's not preclusive, it's not absolutely clear what fits at what level and so on. It's just to give you a general idea. So third level pluralism. This is what I'm going to focus on right now when I talk about these paradoxes. Third level pluralism is 1, mathematical activity at the first, is pluralism towards 1, mathematical activity at the first level of working within a mathematical theory or working with several mathematical theories to prove or verify purported theorems. It's also pluralism towards 2, mathematical activity at the second level of developing a whole mathematical or logical theories or working within a theory to compare smaller theories to each other. It's also pluralism towards 3, philosophical work concerning particular results or notions in mathematics, such as work on the notion of compactness, without having any particular philosophical information, philosophical tradition informing the work. So we talk about compactness results, about different mathematical theories. And there's also pluralism towards 4, philosophical work at the second level of developing a foundational philosophy of mathematics. Now that we have this idea of levels in mind, let us proceed with our paradoxes. So now that was the pre-introduction. Now I start with the real introduction. In this presentation, I shall look at 3 types of paradox which attend pluralism. The external paradox, the internal paradox, and the transcendental paradox. The first 2 are relatively easy, so that will be a sort of warm-up. And the transcendental paradox is hard. The external paradox is generated from the following question. If we are tolerant towards other positions than our own, so think about a moral, tolerant person who, likes the other moral systems or something, then if the other position is intolerant of ours, should we be intolerant towards ourselves by transitivity of tolerance? Oops, I'm missing a page. Where did the page go? Here you go. In more detail, if we claim to be tolerant, then we accept that other positions are to some extent correct. Say we find a position that is dogmatic, so is intolerant towards our tolerance. But we are tolerant, so the intolerance towards us is correct, and we should give up our original position. If we decide that the position is incorrect, then we've failed to show tolerance. So that just gives you a rundown. I'll go in quite a lot of detail through that paradox. The second internal paradox will be relatively quick to deal with. It's generated within pluralism. The pluralist wants to show tolerance and interest in other positions, but he is also insistent on certain issues of protocol or attitude. Is this not itself dogmatic and therefore intolerant? The external and internal paradoxes are solved in a relatively benign way. The transcendental paradox is generated by developing the enclosure schema, which Priest developed in 2002. This is a paradox at the limit of thought, and it is by deploying this paradox that the pluralist transcends his own position. The solution to his paradox is non-standard and so controversial. Okay, so that's a rundown of what I'll be dealing with. But before I actually talk about them, I'd like to talk about the notion of a solution. What counts as a solution to a paradox? The word aporia might be better. I don't know if, do I have that word up there? No. Okay, so this is nice, one of those fancy Greek words. Which Rescher uses. So in Greek, aporia literally means an impasse, a blockage, where there's no practicable way to go forward. The word eventually came to characterize anything, situation, and even person who is difficult to deal with. So you say, you aporia, you. It's a wonderful insult. In philosophy, it came to mean puzzle, a perplexity, an intractable, or at least a deeply problematic issue. Sometimes we use the word antinomy for a solvable paradox, but I shall use the word paradox as ambiguous between having a simple classical solution and not having such a solution. And also the word paradox is much more popular. You know, there are a lot more books that are titled paradoxes or blah, 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 you know, paradoxes in language or something, rather than antinomy or aporias, right? No one would buy a book called aporia. So for the purposes here, I use the following definition. Paradoxes are thoughts or ideas represented by sentences. Again, this is just a simplification, so one could change that aspect of the definition. It's just to make things clear for the talk, which upon initial analysis appear to be both true and false, or appear to be leading to a contradiction of some sort. I.e., they're a puzzle, and what I mean by some sort is that they are a puzzle, perplexity, they're intractable, or at least deeply problematic. To understand this better, I shall develop the notion of analysis and appear to be, as they are used in the above definition of paradox. As I have defined them, paradoxes are not necessarily insoluble. The reason for leaving the ambiguity is to reflect sensitivity to several ideas as to what can count as a solution. If we leave the field open, then solutions might not be quite as we expect. Sometimes we can discover, or only on further analysis, that a paradox was only apparent and it is true and not false, or it is false and not true. These are the simple cases. At other times, such as when we look at the set theoretic paradoxes or some of the semantic paradoxes, we end up in a consistent tension between two poles or attitudes, right? The liar sentence is both true and it is both false, and we just seem to be in that tension. Our finest logical analysis and reasoning bring us to the conclusion that such paradoxes are both true and false. In these cases, if we also assume the validity of ex contradictione quodlibet, we think of the paradoxes as bringing disaster, which is hardly a solution, right? So this is ruled out as a solution. Therefore, in these cases, we are motivated to abandon the theory or modify it in some way. For example, Frege did both. He tried to replace Basic Law 5 with another law. This was what we might call a modification to the theory. When he found that the new proposed law was also led to paradox, he abandoned the project of founding arithmetic and logic and was probably quite depressed because he didn't put pen to paper for 14 years. And he restarted the project very differently. He wanted to found arithmetic and geometry. So he just more or less abandoned everything. More generally, so let's talk about what modifications are. We could, one, find a culprit axiom and change it. For example, we might readjust the naive comprehension axiom in set theory. Or two, we might change the background metaphysical assumptions. So for the set theoretic paradoxes, we could introduce the notion of proper class, right? So this is one of the ways that the proper classes were just very, very big, and we couldn't manipulate them in the standard arithmetic. And they're either paradoxical or they're very close to it. They just sort of flirt with paradox. But we keep them a little bit different because there are certain things that we can't do with proper classes that we can do with the sets. In the semantic case, we have a perfect example in Tarski. He suggested that we restructure our languages so that certain interpretations of paradoxical sentences are forbidden. We organize our languages into a hierarchy and stipulate that we may only attribute truth or other semantic properties to a sentence at lower level in the hierarchy. Such solutions are now commonplace. However, there's a fourth possibility. Instead of adjusting or modifying our theory, or changing the metaphysical background assumptions, or changing the structure of our theory, or how we think about our theory, number 4, we can reject ex contradictione quodlibet and accept the paradox, since without ex contradictione quodlibet, contradiction does not bring disaster. In this case, we do not treat paradox as a disaster, but as a feature, such as a dialetheia, an idea that is both true and false, a true contradiction. In the last section of this paper, I shall discuss this more radical solution to the paradoxes. In sections 3 and 4, I discuss the two paradoxes of tolerance. One paradox of tolerance I call the external, and the other one is the internal paradox. The motivation for the name external paradox is that the paradox is generated by looking at a non-pluralist theory. In contrast, the internal paradox is generated by looking at pluralism itself. So we're moving on to section 3 now. The external paradox. This is going to be a bit long. The next section is actually quite short, so don't despair that the next section is going to be just as long as this one. So the external paradox, again, this is very typical from moral theory or tolerance in politics or something. We want to be tolerant towards other societies, but then other societies, maybe they have a very vicious side to them and they start to destroy our own society. So then we wonder how to cope with that. But I'm talking about mathematics, so it's not as problematic in some ways. In the introduction, I said, in the name of tolerance, if we accept that the other position, the other theory, which is intolerance towards pluralism, is in some sense correct, then the intolerance towards us is correct, and we should give up our original position. Pluralism is therefore unstable in the presence of any position that is intolerant towards pluralism. From the standpoint of pluralism, we end up having to shift position and completely betray our own pluralism and tolerance and adopt the other position just in virtue of its being intolerant towards ours. This cannot be right. Intolerance is no guarantee of correctness, despite what the authorities might try to tell you. The evidence is that there are several intolerant positions that all make conflicting claims about the same subject matter. In fact, very often intolerance, which leads to dogmatism, hides a lack of further argument or resources to defend a position. If one cannot defend a position through convincing argument, one either shifts to a more defensible position, and this is the rational response, right? If somebody gives you good countervailing evidence, then you shift position, not a problem. Or one becomes dogmatic, and this is a much more emotional response, and it implicitly is a rejection of rationality. It's a rejection of trying to negotiate or reason. So then one starts posturing and insisting, maybe resorting to force. Thankfully, this last is rare in mathematics and philosophy. But in other domains, sometimes people do resort to force, right? And all it does is it shows a lack of argument, right? It shows a lack of resources for reasoning about the subject matter. That's all it does. It uncovers something. It uncovers a weakness. This is not to say that dogmatism or insistence is always wrong. It can be justified for practical reasons. One might resort to dogmatism because one's interlocutor is simply not bright enough within some time constraints to appreciate the point one is trying to communicate. If we set aside concerns about time constraints, lack of resources, and level of mathematical or philosophical sophistication of an interlocutor, then dogmatism indicates not correctness, but a lack of rational persuasive resources. Let's move to the specific case of dogmatic philosophies of mathematics. There are two types, monist philosophies and dualist philosophies. A monist philosophical position is one that claims that a particular mathematical theory is the foundation for all of mathematics. There is then a program to work out which parts of what is considered to be mathematics by the institution of mathematics, i.e. academics, publications, and so on. So the institution means the whole practice of mathematics. Which part of this is reducible to or representable in the foundation? Everything we cannot reduce to or represent in the foundation is excluded from being mathematics, right? So that's the sort of typical foundational program. Once we adopt such a position, we make mathematical and philosophical claims at different levels. At the lowest level, so remember the slide on the levels, at the lowest level we have claims strictly internal to the theory. We have theorems of a mathematical theory or principles that characterize the philosophy. So for example, 2 + 2 = 4, or addition is commutative, i.e. A + B is equal to B + A, are examples of them on the mathematical side. An example on the philosophical side is since numbers are objects of our foundational theory in mathematics, their existence is independent of our conceiving of them. So that's just all that we mean by saying that numbers are ontologically real or independent of us. The paradox of tolerance will not arise at this level. So this is fine, and the pluralist is perfectly happy with such comments. It will arise at the next level where we meet claims comparing our foundational theories to others. So again, in comparing our foundational theories to others. Examples of claims at this level are first-order arithmetic has non-standard models, on the mathematical side, or on the philosophical side, realism is the correct philosophy, so that becomes a dogmatic claim. Logicism is an unstable position. Fictionalism is complete nonsense, or fictionalism is rejected by mathematicians. All of these are examples of such statements that the pluralist might have some difficulties with. It is at this level that we find the intolerant claims, such as ZF set theory is the only possible or the only admissible foundation for mathematics, and one does actually read such claims. In other words, at this level, we might make a claim to the effect that our mathematical theory or philosophical position is the only correct or true one. That is, the dogmatism is internal to or comes with part of the theory, and so it directly depends on our first accepting the theory. Such statements preclude other positions. In particular, they preclude pluralism, and the pluralist faces the external paradox. What do? We move up to the third level, right? So it's nice to have these levels. Climb. So we consider the status of the dogmatic claims from the higher perspective, that of contrasting the dogmatic claims to the pluralist claims, or even contrasting the dogmatic claims to each other. So one position holds that their foundation is true, the other one claims that their foundation is true. Well, at most one of them is correct, possibly both are false, so what do we do about this? And so now we're occupying that third level. At this third level, we either retrench our dogmatism and continue to maintain that our own theory is the only acceptable one. We are dogmatic all the way up. Or we are pluralist and refuse the dogmatism at lower levels. So we modify, or if we were dogmatic at level 2, then we might modify or retract some of our lower level claims. For instance, The pluralist recognizes realism as coming from a deep conviction felt by the holders of the position. Right? I mean, the realists really feel this stuff. You know, they really say these are real logic. It's true. It's true that 2 + 2 = 4. Right? You might even think that such realism is useful and fruitful, or as giving motivation for further research and so on. The pluralist refusal to accept the dogmatism as absolutely and finally true amounts to blocking the dogmatism all the way up, but only from the pluralist perspective. That is, it will not convince the dogmatist, only the pluralist. Nevertheless, the threat of paradox is mitigated. We've restored coherence within each, the pluralist and the dogmatist philosophies, and we have a clean draw, right? So one can be dogmatic or one can be pluralist, and it's just a question of being coherent all the way up. With these third level statements, each mathematical and philosophical theory at lower level is tolerated by the pluralist up to the point of dogmatism. So the pluralist doesn't mind the realist, the problem doesn't mind the fictionalist and so on, up to the point where they start making these dogmatic claims. So it's a third level pluralist claim that the pluralist occupying this third level is intolerant towards intolerant claims of others at second level. By refusing to recognize as legitimate particular dogmatic claims, the pluralist solves the external paradox of tolerance only for the pluralist. The solution has an added subtlety. Not only is it a solution only for the pluralist, but the pluralist does not even have to insist on the dogmatism of rival positions as being incorrect. It is enough to remain agnostic and insist on scientific honesty. So Neil Tennant uses this wonderful word. He says, we demur, right? We demur from saying anything. So, and it's more or less sort of principled agnosticism. It's enough to remain agnostic and insist on scientific honesty, that unless we have further evidence for the truth of the dogmatic position, we remain pluralist. Should such evidence present itself, then it is of course correct to give up pluralism. Pluralism includes a principal agnosticism, not a fanatical agnosticism. One argument for such a pluralism is what I call the argument from modesty. It runs. So I have this very modest position. I don't have these very deep convictions. I don't have this strong instinct in my blood or my bones. Yes, so I find it quite interesting that other people do have these very strong senses. So as a modest person, I say there are several different conflicting mathematical theories and philosophies of mathematics. None has succeeded in persuading everyone or even every rational person, unless one defines rationality very narrowly and cleverly. So it's possible to do that. But then I bet you will be begging the question, but that remains to be seen. There does not seem to be an imminent convergence in positions either. Depending on how finely we want to distinguish positions, we might even think that there are an increasing number of plausible positions. Right? There are more philosophers in mathematics than ever before. They're inventing positions occasionally. You know, this thing is growing, right? The whole area is growing. And we're making finer distinctions within positions, right? So we have all sorts of different types of realism. They are not equally plausible, even if we consider plausibility to be a relative term where what is plausible to one person is not to another. Why not? Plausibility also depends on background knowledge, so it is one way of resolving disputes about, this is one way of resolving disputes about plausibility. We can supply the necessary information. The knowledge will include knowledge of arguments put forward in defense of various positions. That something is plausible is an educated judgment, not a mere judgment of taste. Developing the point. So this is actually quite an important point. So it's a little bit, where do we go, right, when we have these conflicts? Comparing Whitehead, so I went to a conference recently in Budapest, and we were talking about the logical foundations of relativity theory. And someone called Desmet was comparing Whitehead's and Einstein's theories of gravity at a particular time in history when they were on a par. So both theories were perfectly good. And he made a very nice distinction between a pure matter of taste and a sort of semi-objective notion, where the latter is one where we can tell a story that accounts for the matter of taste. So if we want to find out, well, why was Whitehead, did he have this particular conception of gravitation, Einstein his conception of gravitation? Well, we look into their education, we look into their influences. There's something to be said, there's something to be told. We might use the metaphor of an educated judgment of beauty, elegance, simplicity, and so on, and compare this to an arbitrary, personal, subjective, and an idiosyncratic one. With the former, so when we're talking about an educated judgment, there's a psychological, sociological, historical, and political story to tell about the learned or acquired sensitivity. With the latter, with just the point about taste or pure idiosyncrasy, there is no such convincing story to tell. Moreover, we can moreover, on the side of having a story to tell, being able to develop this further, we can develop, foster, increase, or on the other side, curtail, discourage, and squash such sensitivities. We can cultivate a sensitivity to simplicity, to beauty. These are acquired things. So what counts as a beautiful proof to one person doesn't count as a beautiful proof to someone else. And there's a very nice talk in Helsinki recently about this and a lot of data about it. So, and we acquire that sensitivity and that appreciation of beauty through our teachers, through our learning, through the courses that we take. And we gravitate towards people that have similar sensitivities. So this is partly our own character, right? So some people, so a very crude distinction is between people who learn mathematics very visually and in several dimensions, and other people are very linear in their thinking, and they just read the symbols. So these are at least two different ways of looking at mathematics. Sometimes people are very general when they look at mathematics. Other people are very particular and they dot the I's and cross the T's. Right? So again, these are just matters of taste. And as somebody with one of these tastes, you gravitate towards the people that teach you these things and help you with cultivating that even further and refining it even further. The distinction between what counts as purely idiosyncratic and something with a story to tell is, of course, a fuzzy one. Right? So there are people that are more inventive might be able to find a story to tell, even though the person who just says, look, I'm sorry, but it's just simple and I have nothing more to say. Someone creative might be able to attribute reasons for calling it simple, or might be able to say more about what that means. So returning from the metaphor back to our judgment of plausibility of a philosophical position, we can partially rank theories or philosophies. One is more plausible than another through argumentation and by increasing our knowledge and considerations by telling the story. But even amongst the most educated, so I'm continuing now with my argument from modesty, even amongst the most educated, we do not have convergence concerning ranking. Future arguments and future information might lead to convergence, divergence, or convergence followed by divergence, divergence followed by convergence. We simply do not know. Therefore, we have no rational basis, nor authoritative basis, based on amounts of education and so on, upon which to make a final choice for one dogmatic philosophy. The pluralist, so where does this come from? So once we have this sort of modest position that we're really not sure, we're sort of agnostic in this very principled way. What does the pluralist think? Well, the pluralist is aware that he's located in time. Right now, while he is a pluralist, he is not convinced by one dogmatic theory. Otherwise, he ceases to be pluralist, and this can happen, again, with enough information, you might change your position. Thus, one can change from pluralism to a dogmatic theory and back again, right? And this will happen over time. It happens with stories, with considerations, with exposure to different ideas, and so on. Taking into account this possibility, this possibly temporary aspect of pluralism, the pluralist is someone who, while being called a pluralist, demurs from making a choice and accepts all of the plausible theories, mathematical and philosophical, as plausible theories. The pluralist may then rank them according to comparative degrees of plausibility, or better, we simultaneously work on the measure of plausibility, right? In what sense are we thinking this is plausible? We work to be explicit about the respects and measures by which one theory is more plausible than another, and then work to come to determinations about those respects and measures through critical argument. The upshot, once one has adopted the pluralist position at third level, is to accept a position at second or first level in the philosophy of mathematics, but excuse the dogmatic second level claims about correctness or absolute truth of the non-pluralist theory. So again, it's just, we tolerate the position up to exactly those words. Once people start to become dogmatic, we sort of, is an English expression, you excuse those ideas. For such a claim is thought to be premature, and the pluralist counters dogmatic claims of a theory by pointing out the existence of alternative theories and running the argument from modesty. Note that pluralism is not dogmatic. Instead, it is principled. That is, upon examination of a position and in light of serious and open critique, one might well decide that one position is more plausible than all the rest, and that the measure of plausibility is a perfectly good one. This is an open possibility. In this case, the pluralist should adopt the position and give up pluralism. However, he will do so in an open-minded way. That is, he will always be willing to change the position, change his mind in light of countervailing evidence. Even the judgment that X is the most plausible philosophy of mathematics is reversible. The judgment is indexed or ultimately depends on knowledge and a set of arguments. So to sum up, the pluralist solution to the external paradox is nuanced and it is partial. So it ends up with a draw against the dogmatist. But the paradox is sort of gone, right? Because there are ways of dealing with this, there are ways of carrying on the conversation that are not problematic. But they're not ways of convincing someone else, unless they're convinced by the modesty argument. Oh, hold on. Oh, where am I? What's the argument for modesty? Sorry, I missed that slide. I'm sorry about that. Anyway. All right, the internal paradox. The internal now again, this is a short section. So, and again, this is a relatively easy paradox. The internal paradox of tolerance comes from the idea that the pluralist wants to show tolerance and interest in other positions, to learn from other positions, to entertain them seriously. But he also insists on certain issues of protocol or attitude. He insists on a fair, honest, and rational open-mindedness. Is this not itself dogmatic and therefore intolerant? Since this is so, it would seem that pluralism is dogmatic in this respect. Uh-oh. We witnessed this in the preceding section too, when we implicitly insisted that if we, from a pluralist position, one comes across an overwhelmingly plausible non-pluralist position, then one should adopt that position, right? That's how I ended the last section. Moreover, one should adopt it in an open-minded way, I said. Oops. That is, in the spirit of revisability. And I said that was rational, right? So I'm being dogmatic here. How can a pluralist defend a theory or philosophy even temporarily, right? The pluralist can do this because he thinks of the protocol and should claims as normative, not as dogmatic or absolute. The difference between normativity and dogmatism is this. So this is quite an important distinction. A norm sets a standard, right? So sometimes it's a statistical standard, sometimes it's just a moral standard. You just set a standard. So it sets a standard of behavior or of attitude. In contrast, a doxa is not merely a standard but is an absolute set of rules. They have to be obeyed blindly, whereas normative claims are ideals of behavior to which we aspire or which we seek to follow. Both adhering to them and following them requires judgment and experience. Remember the stories I was talking about before. The particular norms advanced by the pluralist are common to philosophical practice. This is why so many philosophers are quite pluralist unbeknownst to themselves. They will defend a position until it becomes clear that they should renege that position. Then they change their minds if they're being rational, so I say. Dare I say that ultimately Frege was a pluralist. So I just throw that out for discussion. They will agree to the protocol as norms and not as doxa. And it is in this spirit that the pluralist urges the philosopher to consider these protocols and attitudes. Looked at this way, our threatening internal paradoxical tolerance dissolves into a banality. When debating a theory or a philosophy, we have to keep some goalposts steady. We may revise these one by one, so we can question those norms too if we want to, or even several at a time. In principle, we can question anything, even axioms or a mathematical theory or protocol, but not everything can be questioned all at once, all of the time, and in any way we choose. Such would count as unruly behavior and would be impracticable in philosophy. Thus, by appeal to the distinction between normativity and dogmatism, the pluralist avoids the accusation of inviting an insoluble internal paradox. Those were the easy paradoxes. So that was the internal, external. Is everyone okay with both of those? All right, those are the easy ones. On to the harder one. There's at least one more serious sort of paradox which cannot be so easily resolved. For its generation and solution, we need to equip ourselves with a few concepts and tools. To begin, we turn to the dialetheist. A dialetheist thinks that some contradictions or paradoxes are true. He might not know which ones they are in advance, but he will not rule out the possibility of meeting true paradoxes. Examples of true paradoxes accepted by some dialetheists are the liar paradox or some of the set theoretic paradoxes. But again, there's particular dialetheists might reject or accept different ones. These are then considered to be true contradictions and are called dialetheists. Now, I'm not sure what I have is at the next slide. So yes, that's good to have. We might have found some. So I'm on to section 5, which is when I. What do I do here? Yes, okay, so I'm just setting things up for this transcendental paradox. We might have found some resolutions to the paradoxes of tolerance, the external and the internal paradox, but we suspect that there might be other paradoxes facing the pluralist, not least because he entertains, discusses, and takes seriously not only pairs of theories that contradict each other, but also quite disastrous theories, such as trivial theories, and there's one that considers trivial theories in this room, or logically outlandish theories, such as one with a relevant logic underlying them. And I'm sure there are people in this room that occupy that outlandish position. That is, theories that entertain the notion of a contradiction, but are not for all that trivial, at least not in the very grave sense of everything goes. We might be afraid that the trivialism and contradictions affect or infect the rest of the discourse, and so there's a logical risk in being tolerant. The risk is that our very own discourse collapses into trivialism. So now I can speak complete nonsense, and I can say what I want, and there are 4 elephants in the room and so on. Most of you will be aware of the fact that there is a perfectly robust distinction between a theory containing contradictions and a trivial theory. But let's rehearse the distinction, because I might say it in a slightly different way, or I might be saying things that that will set what I say up a little bit better for the context of this paper. This distinction between a trivial theory and contradictions is drawn by what we call relevant logicians. For them, The inference ex contradictione quodlibet inferences are invalid. We all know what those are, right? Good. We cannot conclude anything from a very restrained set of statements that are still relevant to the contradiction. For example, if our domain includes a round square, so we're reasoning about round squares, we are allowed to validly conclude that it is round, or that it is not only round, or that it is square, or that it is not square, or that it is both round and square, that it is square and not round, that it is an impossible object, etc., provided we have linguistic resources in the theory to express all of this. In contrast, we may not conclude that Mexico City is on the moon. Such a conclusion is invalid, since it's not relevant to the impossible object, the round square. Mexico City on the moon is simply false and not true for the relevant logician arguing about round squares. So to provide one sentence which is false and not also true is enough to make the semantics non-trivial. Call this, I'm going to call it post-non-triviality. Yeah, so this is after Emile Post. The reason I call it this is a little involved but not uninteresting. So here's the reasoning. Post gave us the following definition of completeness of a theory. A theory is post-complete if and only if every time we add to it, so to the theory, a sentence unprovable in it, we obtain an inconsistent system. So take arithmetic. We have 2 + 2 = 4. We have 2 + 6 = 8, and so on. We have all these nice true things. And it's complete in the sense that if we add anything more of that nature, then we're going to add in a falsehood, and the whole thing starts to collapse. So it's complete in the sense of it's maximal. You can't allow any more, right? It becomes full. In other words, there's something maximal about the theory. We cannot squeeze anything more into it without generating inconsistency. Of course, Post was assuming that ex contradictione quodlibet holds in the theory. Post then defines a formal system to be inconsistent, and I quote, if it yields the assertion of the variable p, end of quotation, where p, no, sorry, not end of quotation. Here's the quotation. If it yields the assertion of the variable p, where p allows us to derive any sentence as a sentence in the theory, end of quotation. Again, the theory has as many sentences in it as possible without collapsing into triviality, given ex contradictione quodlibet. Now we can modify the definition a little and make it serve our purposes. So I'm going to use, talk about post non-triviality. That's at the bottom of the slide. A theory is post non-trivial, so I just use post as, in order to understand where the history comes from. If and only if there's at least one formula in the language of the theory, which we can express in the language of, sorry, that doesn't make sense. Do I say the same thing? That's a bit strange. There's something missing, isn't there? Yeah, okay, I'm not sure why. All right, so, but you heard what I said, right? So, all right, so a theory is post non-trivial if there's at least one formula in the language of the theory which we can express and is only false. Okay, so if you have a sentence that is only false, then that's enough to make it post non-trivial. Because remember, a trivial theory, everything is both false and its negation is false. So if you have a bivalent logic, so you only have 2 truth values and 2 of them can come together as well. So I'm using bivalent not in the exclusive sense of bivalence, but where you just have 2 truth values. Then, sorry, I'm a bit jet lagged because I had difficulty getting here. What am I trying to say? Yeah, so if you have a sentence that is both true, well, if it's true, then it the negation will also be true. And if the negation is true, then the assertion will also be false, and so on. If you have a trivial theory, then you have just rampant trivialism. And if you have one sentence that is only false, or can only be asserted in one way and gets one truth value, then that's sufficient to make it post non-trivial. Okay. So, all right. Of course, this will not be a very useful theory if there's only one falsehood that is also not true. What we want for workable theories is that there is a substantial set of only true sentences, a substantial set of only false sentences, because we want to be able to correct people more than almost all the time except for one sentence, right? And maybe very few sentences which have two truth values. So this is a nice way of exploring this notion of a trivial theory and what that looks like. What do we mean by very few contradictory formulas? What we really want is to be able to, most of the time, distinguish the class of only true, only false, and dialethic sentences. True and false sentences, which enjoy a glut of truth values. We use the true or false ones to do most of our reasoning over the dialetheas. So the optimal distribution for a workable theory is as follows. In an argument, exploration, discussion, there are fewer dialetheas than only one true or one false sentence. More usually, there is only one dialethea, or possibly two dialetheas, or a bracketed class of dialetheas that we are discussing using only true sentences or only false sentences, at least prima facie as far as we can tell. And one of the problems with the paradoxes is that sometimes sentences inform each other, and then you get these sort of big loops. But if we limit our discussion to this particular discussion, we want to be using at least only sentences that have only one truth value at a time, and then we can talk about the dialetheas. In fact, we want quite a high proportion of only true sentences. So let's express this in English. I'm not sure if I have this in the next. Yeah, good. Okay, for any set of formulas used to argue about an inconsistent object or a class of inconsistent sentences or formulas, the majority are only true. At most, a minority are only false, and the inconsistent objects or class of inconsistent formulas is bracketed off, mentioned and not used for the purpose of argument. Call this a locally consistent argument or set of sentences about contradictory objects or theories. So I picked up the word locally consistent from a talk recently by Abramsky, who's interested in quantum logic and quantum theory. And he was talking about locally consistent arguments, and he has a sort of topology that he imposes on the arguments where he works out where the contradiction is going to arise in quantum mechanics. And as a scientist, as soon as he gets very close to that, he wants to back down from it, right? So he wants to stay consistent within his theory. So he's well aware that there are contradictions in quantum mechanics. And the point is, as a scientist, you want to stay on one side of that inconsistency. As a philosopher, we might be very interested in what happens on the other side, or what goes on. So he distinguishes between local consistency and global inconsistency in a theory for the purposes of discussing and arguing about quantum theory. Here we have been a bit more tricky than Abramsky, since we are specifically using consistent arguments to discuss inconsistencies. This all sounds fine and looks like a description of how it is that logicians and philosophers, in fact, do discuss contradictions, paradoxes, and inconsistencies. Right? So if you look at any textbook on paradoxes and inconsistencies, the presumption is not that every sentence or the majority of sentences being used in the text are inconsistent. Right? They are consistent within particular arguments that are about the questionable phenomena. In fact, in exactly this way, logicians and philosophers treat paradoxes as a feature, not as a disaster. As long as arguments about paradox take this form, we should be all right. Have we really averted the problems? Unfortunately, this is not enough. We have not abated the transcendental threat. The situation is much worse, and it's going to get worse, even 2 times worse. The problem comes when we apply the enclosure schema to our pluralism. This is a formal schema for generating paradoxes. The enclosure schema can be used in the presence of any large or all-encompassing theory. All we need is a little ingenuity in interpreting the schematic letters. All right, so it's fairly technical, and I'll talk you through it. Before I give the full definition of the enclosure schema, let me make a few general remarks. The enclosure schema is a partial, because schematic, recipe for generating paradoxes, some of which are dialetheas, possibly all of which. A prototype of the schema was originally developed by Russell as a diagnosis of what is common to the set theoretic paradoxes. Priest in 2002 generalizes Russell's schema, calls it the enclosure schema, and uses it to expose paradoxes implicit in many philosophical positions. Some of these paradoxes are then thought of as dialetheas, logical or conceptual limits to the philosophy. So that's the end of the general remarks. I'll now introduce the enclosure schema to later use it to produce a dialetheia about pluralism. There are 3 conditions that have to be met to produce a contradiction by means of the enclosure schema. The first one is existence. Second is transcendence, and the third is closure. For those unfamiliar with the enclosure schema, I'll quote it verbatim and then discuss it. So a contradiction. So that's the, I don't know, this thing. A contradiction fits the enclosure schema if and only if it has 2 characteristics, existence not being a characteristic, so it's a separate precondition. And we have this big omega is equal to the set of x such that phi x exists and psi omega. 2, for all x, which is a subset of omega, such that psi x, then we have the 2 subconditions. I had to put them all on one line. I had to do with the slide and how it worked, but one is one of the subconditions. Gamma of x is not a member of x, and delta of x is not a member of x. Delta of x is a member of omega. Deciphering. So let's work through this. So number 1 is the existence clause and sets out the terms for the next clauses. Omega is the set of all sets x which have the property phi and have some other property, and some other property psi can be attributed in turn to omega. In our case, the property phi will be is a characteristic or combination of the characteristics found in the philosophies of mathematics. So if I can use the board, so say we have so if we have 3 more traditional philosophies of mathematics, so these are not pluralist philosophies. So the property set of all sets of x such that we have the property. Right. So phi is a characteristic or combination of characteristics found in the philosophies of mathematics. So here are the characteristics. Okay, so those are the characteristics. The set omega exists. So this is just take all of those characteristics together. It is the set of all the collections of characteristics found in the philosophies of mathematics to date. At any one time, there are only finitely many of these. We can think of this global set as giving us some materials for a global pluralism. So this is a little bit different from third level pluralism. Global has got everything in it. In our case, the property C could be made into a philosophical position. So say now I decide to combine a new philosophical position. I have A2, C1, D3, and so on. So I just sort of mix and match. So we took all of the philosophies of mathematics with all the characteristics of those philosophies. Then we have the conceptual possibilities that are presently in the playing field of philosophy of mathematics. So the idea is that we can mix and match in any way we choose, and we'll have a different philosophical position. They might not be all very good, right? Most of them will be rubbish. We implicitly have lots of new philosophies of mathematics, right? So now the worlds have exploded. Now we have research program, we have lots of PhDs coming in. For example, we could combine naturalism with fictionalism. I had a talk recently that did this. And all sorts of glorious and wonderful positions. Considering all the positions together, there are a large but finite number of such possibilities. So again, we have only finite numbers in here. We can't repeat the sentences too many times because it becomes boring. So, or only a finite number of times. So we end up with still a finite number of possibilities. Reasoning over this whole set of possibilities is exactly what I've been doing and call the position from which I'm doing this global pluralism. So that's my big omega. So I'm sitting in this global pluralist position talking about all those possible theories, about the whole field of play within which we can generate PhDs in philosophy of mathematics. Returning to the schema, C is a modal property, since could is a modal term. There is no guarantee in advance that whatever could be made into a philosophy will be an interesting, strong, or stable position. Some possible philosophies will be weak, unstable, boring, trivial, or nonsensical, right? That's when you don't get the PhD. So the claim, C of omega, is that it is possible to make a global pluralism out of all of the characteristics of philosophies of mathematics. Success or interest is a separate matter. Maybe candidate philosophical position is better, but we omit the word candidate as distracting complication. All right, so now deciphering 2. So we're going down to number 2. Where's 2? Yeah, 2. We start with the subsets X of omega, i.e. all of the second level philosophies of mathematics and all their combinations, plus third level pluralism, and so on up to global. The subsets X are potential philosophies. These can be scrutinized in the light of pluralism, since many of these are made up of combinations of other philosophies, monist, dualist, and suboptimal, optimal, maximal philosophies, and so on. Some combinations of these will lead to nonsense, such as fictionalist theories, a fictionalist theory which is combined with a philosophy which is realist in truth value and is classical. So that's when you end up with a sort of trivial theory. Such a combination is nonsense because it is sort of globally trivial. Both fictionalism and realist in truth values philosophies that are classical endorse ex contradictione quodlibet, and therefore the combination results in a trivial theory. Optimal here refers to the distinction between optimal and maximal pluralism. An optimal pluralist is a pluralist towards successful mathematical theories, and success is measured in a certain way, as being accepted by the mathematical community and being describable as a structure of model theory, for example. So Stuart Shapiro's, he considers himself to be a pluralist because anything that fits a structure of a certain sort then ends up being a viable mathematical theory. A suboptimal pluralist will develop a pluralist philosophy, not monist or dualist, in the sense of including several mathematical theories, but is neither interested in success nor in a maximal pluralism. For example, we might think of a geometrical pluralist, someone who accepts all the received geometrical theories as on a par. There are many suboptimal pluralist philosophies, and I suspect that some mathematicians who call themselves pluralists are pluralists in this suboptimal sense. So I've talked to a number of philosophers that say, oh, I'm a pluralist, but they're really talking about pluralism of the theories within more or less the area that they're using. Thus, the first part of 2 says that for all subsets of a global theory which are possible philosophies, we can transcend the subset theory 1 while staying within the global theory, clause 2. More specifically, we start with this transcendental part 1. Delta is our diagonalizer. So we all know diagonalization in Cantor.
Yes.
Yes, good. In our case, it will read, so here's our diagonalizer here. Reorganize the philosophy by adopting a different underlying logic. At the third meta level of our discourse, for example, we might use a relevant logic to underpin our fictionalism rather than use a more common classical logic. By diagonalizing, we step out of X. We transcend our subtheory. Moreover, clause 2, the diagonalized X is a member of the notion of a global pluralism, omega. This makes sense since omega is a global theory. We can now use the enclosure schema to create a paradox. Diagonalize omega by switching underlying logic. The diagonalized omega transcends omega itself, but it could not have done since delta omega is a member of omega, according to 2. So we have a contradiction. If we consider global pluralism, then we can generate many pluralist philosophies, and we can generate a paradox. The idea of a position suggests a finished entity, the global pluralist position. But it is not fixed because by its very nature, because of its pluralism, it grows. Running the diagonalizer is tantamount to doubting the locally consistent idea that I canvassed above. In fact, there may be a diagonalizer that does just that quite explicitly. I've not had the time to formulate it, so that's a PhD that someone can write. Nevertheless, this might be an easier way of thinking about giving an instance of the enclosure schema. So call the paradox generated by the explicit diagonalizer suggested above the transcendental paradox. Since we can think of other diagonalizers, this becomes a family of paradoxes. So I'll return to this in a moment. So let's just stay with what I call the transcendental paradox, which uses the one diagonalizer, change your underlying logic. What are we to make of it, of this transcendental paradox? First, is it a dialetheia, i.e., is it a true contradiction? The paradox we have generated using the enclosure schema gives some philosophers and logicians a reason to find global pluralism unsavory because dialethetic. Nevertheless, unsavoriness is not a principled reason for ignoring the theory by our own pluralist precepts, right? This is the dogmatism I talked about with the internal paradox. Therefore, we should, normative should, consider it if we have the time and the energy. So let's entertain the idea that it is a true contradiction. The next problem is how to cope with true contradictions of this type. The reaction of finding global pluralism unsavory is a conditioned reaction. So now I'm starting to tell that story that I was talking about before. It is conditioned by our upbringing in classical logic. In the literature, there are enough arguments supporting the thesis that this particular aspect of our upbringing is not feasible, and I refer the reader to these. So Priest in 1995, 2006, and so on. Overcoming our upbringing, or turning to other traditions, we can think of global pluralism as an extensionally growing philosophy. It is not, for all that, intentionally growing. And that's intentional with a T, right, in terms of my intentions towards things. Although it is intentionally growing, intentionally with an S, it's growing because the mode of presentation changes. The end tension with a T is fixed. That is, global pluralism is an intention, again with a T, to entertain, to evaluate any proposed philosophy of mathematics, including ones made from a combination of others. The task cannot be completed, and we have no guarantee that we can ever reach a final decision. The best we could cope for is relative stability. For this reason, global pluralism is not as chaotic as it appears at first glance, since we take time to develop and evaluate philosophies. And there are only a small number of people who do this. So we don't want the community of philosophers and mathematics to grow too fast also, right? Because we can do things step at a time. So at any one time, we have relative stability. It is not the case that anything goes. Since we cannot see anything all at once, we are saved by a notion of time, process, or piecewise development. In our practice as philosophers, we build and consider positions which have some pedigree, positions which have been received by the community of philosophers and mathematics. We build on each other's shoulders, not in the void. Construction and evaluation take place within a community, and therefore, to develop the metaphor of chaos, we do not have chaos, but anarchism, that is, a self-regulating community. We therefore have the option, nay constraint, to confine our research, our historical situation, our finiteness, and the small number of people in the community together bridle global pluralism. So it should not be thought of as threatening. Does this really work? Conclusion. To sum up, if we take a paraconsistent logic to underpin our pluralism, and we think that pluralist philosophies of mathematics taken globally contain dialetheas, then we think that pluralism commits us to recognizing some contradictions as true. The dialethic response is to think of pluralism as a transcendental position. It is a family of positions, and as soon as it is taken as a whole, it is then transcended. The global theory grows. The situation is not as bad as it might seem. For one, we are in good company, the company of almost every leading philosopher: Plato, Aristotle, Aquinas, Leibniz, Sextus Empiricus, Berkeley, Kant, Hegel, Russell, Frege, Quine, Davidson, Wittgenstein, Heidegger, just to name a few. Right? Apart from the good or bad company argument, we can think of the dialetheas this way. Moving up a level from third level dialethic pluralism, we take seriously the idea that there may be rival logical underpinnings, each meriting its own take on the lower levels of analysis. After all, we could just choose a different paraconsistent logic, since the term paraconsistent is adopted in quite different philosophical and logical traditions. Each has its own motivations and will bring its own philosophical stamp to bear on its version of pluralism. For this reason, we can really discuss global pluralism as a fixed entity, and this may not be so difficult to concede. However, we should be careful. The paradoxical is worse than I've described, and I sort of hinted at this a little bit before, since, remember, the enclosure schema makes for a family of transcendental paradoxes. In other words, we could choose different diagonalizers, we could choose different omegas and so on, and then we can regenerate paradoxes, right, really relatively fast. But I'm going to run the same argument again, right? I'm going to say again that what saves us is the fact that we're situated in time, that there's a practice, there's an institution, mathematics or philosophy, that we can only do a little bit at a time. We can't move all the goalposts at the same time. I wonder if I should say any more. I think I'll end right there. So the dialethic position is not, or the transcendental position of pluralism is not as disastrous as we might think, simply because of this, the fact that we're also wedded to a practice as a process of developing a philosophy, and that process takes place within a community. I think that's it. Okay.
Would you like to take some time for a cup of coffee, or shall we proceed to the questions and answers?
Like an hour, right?
So we should have time to have a coffee if you like. I don't mind.
As you wish.
You're the chair.
Okay, so let's proceed with the questions and answers section. Okay, so any question? Axel.
Yes.
And thank you for coming over. But I really like this delta solution, but I like a lot the way you also presented the dialectic since the beginning.
Mm-hmm.
That what pluralism are being tolerant about is about ways of doing philosophy and ways of doing mathematics.
Mm-hmm.
But then you forgot about it and you started talking as these are things that could be accepted or rejected or true or false and things like that.
Right,
and
right.
It seems you have left the activity thing behind.
Right.
But if we bring it back to the transcendental solution, then it becomes even more appealing. Because of course we cannot do everything. So of course again, if we were tolerant to this position doesn't mean that by being tolerant we're doing that. So we're always going to be doing a finite number, or we're going to only bring some characteristic for every decision we make or every theory we prove and things like that. So if we think of it that way, then it's even more plausible.
That's right. Yes, that's exactly correct. So yes, well done.
Yeah, hi. So when you first started talking, I was thinking that pluralism was going to be some wacky view where Platonism and fictionalism both come out true or something like that.
Mm-hmm.
And then I quickly abandoned that. And I was listening to you, and I started thinking that the pluralism sounds like a methodological principle about how to assess views like Platonism and psychologism and fictionalism.
Mm-hmm.
And then the external paradox was, what do we do if we come on a view that's not tolerant? And I thought, well, pluralism is a thesis about views that are silent on whether to be tolerant or not, because they're philosophies of math. You could combine Platonism or fictionalism with a methodological view that says be intolerant.
Right.
And then you can just go, yeah, well, my pluralism is a pluralism about the philosophies of mathematics and how to assess them. It's not a pluralism about methodological views. That methodological view is just false. And I wasn't sure if that was actually your solution. I'm just saying what you said in different words, or if I'm saying something different.
Well, stay tuned for the next talk, because I'm giving a talk on varieties of pluralism. And so I do discuss pluralism in truth value, pluralism in ontology, pluralism in methodology, as being sort of different axes upon which one might be pluralist. And this is more to do with the notion of optimal pluralism. So someone might decide that they're going to be methodologically pluralist. So they decide that different methodologies within mathematics are perfectly okay. Or they might be pluralist in truth value, so there are going to be different theories that are true or something. So there's a more subtlety to be added to that, yes. But that's a nice way of thinking about it. And I do often shift within pluralism to, I play a trick, right? So I'm not supposed to say that, but I do. So the trick is to, when you get into trouble, turn it into a procedure, right? So you then say, well, all right, so we have this problem. What do we do with it? Well, turn it into a process, turn it into a procedure, so that now, what's your first port of call? Well, okay, so we see this thing that's called a paradox. Well, let's try and get rid of it in the nicest way. We put some indices on it or something. Or we contextualize it, then we've gotten rid of it. But say it's sticky, right? It's really hard paradox. So then, sort of what do we do next? And then there are different options. So one of them is to adopt a relevant logic or a paraconsistent logic. And then they give us different methods of dealing with this. They have their own philosophical ideas. So, and then one of, this idea that I have of telling the story, that's again a sort of methodological principle. When you get stuck, start talking about the history and the psychology and the community or something. So I'm not sure. I mean, the goalposts start to shift in a funny way. And I don't have a strong story to tell about when that should happen. Does that help?
Not bad.
Any more questions?
Michèle, I'm not sure I've got my head around how the enclosure scheme is supposed to work here.
Okay.
So, let me walk you through it. So you've got all these different philosophies, and they've got
Right.
these different characteristics.
Right.
Yeah.
Right.
Omega is the set of all these characteristics.
Right. Good.
Okay.
I think.
Okay. Well, it's just a set containing A1, B1, C1, A2, B2, C2, and so on.
Yes, and then we understand that there are these subsets which are the traditional philosophies.
Okay. So a philosophy is characterized by a subset of these characteristics.
Good. Yeah.
So if you take a subset of omega,
Mm-hmm.
you can think of that as a philosophy characterized by those characteristics. Okay. Got that so far. Now, I wasn't sure what delta was. So
Okay.
you take one of these theories and you said, when you apply delta, you change the underlying logic.
Right.
That sounds to me as though you get a new theory.
Right.
But if you look at the conditions, when you apply delta to a set, you've got to get a member of omega.
Oh. Except that but you get a member of omega in an odd way, right? I might not
Well,
understand the enclosure scheme.
Well,
at
I'll
all.
just split back up the conditions.
Okay.
So,
That was already there, or in principle, I forgot to add it in.
no, my problem is, look, when you apply delta to one of these x's, which is a
Right.
philosophical theory,
Right.
you've got to get something which is not in x. Okay, and x is a bunch of characteristics,
Mhm.
but it is in omega, and omega is a bunch of characteristics.
Mm-hmm.
So when you apply delta, you should get a characteristic.
Mm-hmm.
Now, you said when you apply delta, you get another theory, which you get by changing the logic.
Mm-hmm.
So according to you, when you apply delta, you get a theory, not a characteristic.
Right. You get you get a combination of. That's true. I'm not sure if this works, but you get a new set of characteristics with
okay.
a different underlying logic.
That's okay. I understand that if you take a theory, you change the underlying logic, you get
Right.
a new theory.
Right.
That's
Okay.
fine. But that's not what the enclosure scheme requires. When you
Okay.
apply delta,
Right.
you've got to get something that's in omega. And something that's omega is one of these characteristics. So think
Okay.
of
Okay.
Raleigh-Fortis paradox.
Right.
If you had a bunch of ordinals,
Mm-hmm.
you diagonalize and you get the least ordinal which is not in there.
Right.
So when you apply delta, in this case, to a bunch of ordinals, you don't get another bunch of ordinals, you get one ordinal.
Mm-hmm. Mm-hmm.
Okay. So when you apply delta, you've got to get a member of omega.
Oh, I see. Okay. Okay. Okay.
And
Okay.
as you describe delta,
Okay.
you don't get a member
You're right.
of omega, you get a subset of omega.
Right.
And then you get another bunch of
Okay.
characteristics.
Okay. Let's try a shift. So. All right. So there, instead of particular individual characteristics, omega has as members these whole theories.
Okay.
All right, so in each, this is a member, that's a member, that's a member, that's a member.
Okay. So now you want data to apply to a bunch of theories.
Right, right.
Good. So you're not just applying to a single theory, you're applying to a bunch of theories.
Correct.
What are you going to get when you apply delta?
I'm going to generate a new theory.
Okay, how?
By taking this, say it's a fictionalist theory of philosophy of mathematics, and if I apply relevant logic or something, then I'm going to generate a new.
Well, if you take any of these theories and change underlying logic, you're going to get a new theory. But remember, you've got a whole bunch of theories. You've got a set of theories, and you want to diagonalize out of that set. So, do I change the underlying logic of every theory in the bunch, or one theory in the bunch, or?
Well, I only need to change one, right, to diagonalize that.
Okay, so suppose I choose one theory in the bunch and change the underlying logic.
Right.
Okay, so now I've got a theory. That's the right kind of thing. And since it's a theory, it's an omega. That's good. Okay,
Right.
you're halfway there.
Right.
How do you know it wasn't one of the theories in the bunch you started with?
Right. Not sure.
Okay, because that's the other half of the condition
That's
you
right.
need.
That's right.
So maybe you can do it this way, because omega, well, this bunch of theories has got to satisfy some condition.
Right.
What did you call it? Psi.
Yeah.
Okay. So you might want to take psi to be some condition which rules out the possibility that modifying one of the theories in this way generates a theory in the bunch. I'm not quite sure how to set it up at the moment, but if you just start with an arbitrary bunch of theories, take one of them and change the underlying
Then
logic.
it probably was in the,
There's no guarantee that it's going to be different from
right,
all the theories in the bunch.
right. That's
So
right.
you've got to arrange that
Yeah,
somehow.
Yeah.
So
I've got
you've got to fiddle around with psi
I do,
to
yeah.
give you that, I think.
Okay, I agree. Yes, thank you. I'm so glad that you're here to help me with this. So, what we might avail ourselves of is the notion of a sublogic, a logic that's weaker than another one. So we have a set of theories under some sublogic or some weaker logic, and then we use a stronger logic to diagonalize it out. But then it should have been part of the initial set.
All right, okay. So why don't you take psi to be that every theory in X has the same underlying logic?
Right.
Good. So now choose any one of that, change underlying logic, then you're going to get a theory which is not in that set.
Yeah.
And it's going to be a theory. So you're still in omega.
Right.
Right?
Is it? Is it still going to be omega?
Well, it's a theory.
Okay.
Yeah, so and omega now contains the theories.
Right.
Right. So you've got transcendence, you've got closure, but now you've got to worry about the first clause, omega. Okay? And that's got to satisfy the condition psi. And the condition psi was that all the theories had the same underlying logic. Now that doesn't seem to be true of omega.
Right.
If
Right.
omega is a set of all philosophies, right?
That's right.
So that
That's right.
won't seem quite right either.
No. Do you have a suggestion?
Yes, I don't know if you wanted to make like a more direct diagonalization, can't you group characteristics as different positions of on a certain question? So you have a sequence of questions, and then you characterize every theory by a sequence of answers to these questions.
Okay.
So then you do have a string, kind of string for it. Right. And you can order them, and then you can get an actual diagonal. So like it changes regarding to the first theory, you change the question for the answer to the first question to the same. And that way you will be able to get a theory that is a diagonal, and it's not going to be, it's going to be a theory, a philosophy of mathematics, but it's not going to belong to it.
Right, or it's going to be an answer to a question in the philosophy of mathematics.
So that would be a theory, wouldn't that work? I think so, right?
That sounds promising.
Yeah. we'll work on it. So take, say, the ontological question, whether the ontology of arithmetic is real. Okay. Yeah. And your philosophies, and we're supposed to be pluralist about that. So there should be different answers to that. Yes. So your set is the set of answers.
You have all the issues in which different philosophers of mathematics can disagree. You have presumably
all of the issues.
All the issues. Yeah, long list, right?
Okay. Big
yeah, exactly. It's long list, and then you characterize in every philosophy of mathematics by the set of answers.
Oh, I see. Yes. Okay. Okay. So you're interested in the C's here.
Exactly. So yeah, exactly. All the C's are going to be.
Okay. What they say about ontology.
Right. So this is the third question. Then the third theory, you're going to change that answer.
Okay.
And so if you do it that way, so then you don't have just set of characteristics, but you actually have a sequence of characteristics, and a sequence of theories.
Right. And I just bump those, yeah.
Exactly.
That's right. Okay. Right. And I just kind of shift them over, right? Or something.
Right.
Yeah, that may well work.
That may.
Yeah. Thank you.
Sir?
Yeah. I might be not understanding something, but by these different philosophies, we're talking about philosophies of mathematics, like Platonism or something. Mm-hmm. Okay, so then I'm thinking, what are the characteristics of Platonism? Well, the only thing I can think of is it's just a set of claims that Platonists make, right? And so here's a shot at it. Platonism just has two characteristics. It says there are abstract objects, and it says our mathematical theories describe them. Mm-hmm. It doesn't look like there's an underlying logic at all. It's neutral on anything about the logic. So you could have many different Platonist views, I guess, with different logics, but Platonism itself doesn't have a logic.
Right, so there's going to be sort of, there might be theories here that just don't contain C. Right, that just has A and it has, really.
Sorry, but my worry was then if it doesn't have a logic, you can't change the logic.
No, but all I need to do is diagonalize out, right? So I don't need to scoop everything up in my omega. So I could say, philosophy has to be complete under some sense of complete, but I don't think I need to do that. I think you can have sort of degenerate theories that are just not well thought through yet. So sometimes I talk about what I call nascent theories, ones when you haven't quite worked everything out yet. So you've started the philosophy, but it's not a completed philosophy. So far you're wedded to the idea that there are abstract objects. You're wedded to the idea that we grasp them in some sense, and you haven't quite decided on the logic yet. And you haven't quite decided on how to treat truth values regarding sentences about those objects. And you haven't quite decided, but as you develop your theory, what are the implications of those two things? You're going to start to find yourself making a few more claims. So those would be sort of degenerate beginning philosophies. And to use the diagonalizer, I don't think you need to push on everything that's inside omega. I think that's correct. Experts there.
Some more questions? Okay, so my closing session. Thank you very much, Ms. Friend.
Thank you.
So now you're free to take a coffee.
Okay, thank you very much.
No, thank you. I had just a general question. So at the beginning, I was thinking more or less on the same lines as, and I thought that you were trying to characterize that pluralism as a sort of methodological principles, to treat it's rival philosophies of mathematics, right? At the end, this whole procedure starts to go beyond that kind of methodological pluralism.
Yes,
And you're trying to generate a procedure in order to, perhaps to generate maximally consistent sets of theories, right? So yeah, the whole structure, of your talk was how to go beyond just normative pluralism to a more substantial form of pluralism. Thank you very much.
So those, the next talk that I give will be also on these varieties of pluralism, so different axes upon which one can be pluralist. So then the landscape starts to change again. But right now I just wanted to deal with certain, because a lot of people say, oh, if you're a pluralist, if you're tolerant towards everything, then you run into paradox. So that was that question today.
A more basic one.
Yeah.
Okay, so you can transform pluralism into something more.
Yeah. Once you've transcended, right, you can do all kinds of stuff. So.
Okay. Once you deal with the paradoxes and
that's
you
right.
can transform it into a substantial.
Then there's all kinds of stuff that happens. Yes, is that you're not blocked by the notion of paradox.
All right.
So now that you're not blocked, then things open up in a lot of ways.
Okay.
Yeah.
Thank you very much. Nice talk.
Good job. I love your lecture. And my question is, would you mind signing my book? It's only a photocopy of your book.
I can even give you a hard copy.
Really?
Yes, which I can sign.
Well, you don't have to.
No, I brought some.
Okay.
The publishers yesterday.
I appreciate that. Thank you very much.
And